guys, today's lesson is the second part of our arcs and chords lesson. So today we're going to mainly focus on the relationship between arcs, chords, and central angles. All right, so let's take a look at this first theorem. It says congruent central angles have congruent chords. Now what that's talking about here is if you have two central angles that are equal, then that means that their chords are also equal. Okay, we learned that central angles have the exact same measure as their arcs, right? We know that if the angles are equal, these two arcs are going to be equal. Now, the idea here is that if those arcs are equal, that chord that connects the endpoints of those arcs, D and E, and C and B, they're congruent. So those two segments are equal right there. Those chords are equal. Okay, look at the next one. Congruent chords have congruent arcs. So basically, if you have two chords that are equal to each other, right here there's a chord, and here, and if you have two chords that are equal, then the arcs themselves will also be equal. And the last one says congruent arcs have congruent central angles. So if you know that the arcs are equal, then you know the angles are equal. And we learned about that in a previous lesson. Okay, let's take these rules and apply them to some problems. All right, let's look down here at this first one. Okay, so it says we have to find the length of QR. Now, what do we see? We see that we have a chord here and a chord here both equal to each other. If those two are equal to each other, then this arc here is equal to this arc here. So these arcs are also equal. If the chords are equal, the arcs are equal. So we can set those two arcs equal to each other. So 3x, and that should be a plus there. It's hard to see. 3x plus 22 is equal to 4x. So we set them equal to each other. We're going to subtract 3x on both sides. And when we do that, we get left with x equaling 22. Now, it says to find QR, so you have to plug it back in. QR was equal to 3 times x, and x was 22, plus 22. So that QR there works out to be 88. So that is the measure of arc QR is equal to 88 degrees. All right, let's look at the next one. In the next one, we see that we have two angles that are equal. We have two central angles there that are congruent to one another. And if the central angles are equal, then that's going to tell us that the chords are equal. So we now know that that chord and that chord are equal to each other. So we're going to set those equal. That's 2y plus 5 equal to y plus 13. Okay, let's subtract y on both sides. You end up with y. Subtract the 5 on both sides. We end up with y equaling 8. Now, it asks us to find the length of GH. So for GH, we have to plug it back in. 2 times the 8, which is our y value, plus 5. And when we solve that, we end up with GH equaling 21. So the length of segment GH is 21 there. Okay, let's look at a few more rules that go along with arcs and chords. Okay, in this next one here, this is an extremely useful concept. This says, okay, in a circle, if a radius or diameter is perpendicular to a chord. So this could also be a diameter. This could be continued like all the way up. Okay, it doesn't have to be, but it could be a diameter or it could just be a radius. Okay, if it's perpendicular to the chord, so if you have a right angle here, what that means then is that that radius bisects the chord. It's going to cut that chord in half. So this little piece here is going to equal that little piece over there. But not only does it do that, it also cuts this entire arc in half as well. So it cuts the arc also in half. So it cuts the chord in half and it cuts the arc in half. So we get two things that are equal out of this. If the radius is crossing the chord at a 90-degree angle, it's cutting the chord and it's cutting the arc. In this next theorem here, it says, in a circle, the perpendicular bisector. Now, here's the thing. You have to have the right angle. You have to have these two parts equal. But if you have that, if you have two equal segments and the perpendicular, that means then that that line segment, AK, has got to be a radius. Or we could also say that JK is a diameter, either or. So we could say JK is a diameter, or we could say AK is a radius. Either one is true based off of that rule. All right, so the key thing that we have to take away is this. Anytime you have a radius perpendicular to a chord, okay, radius perpendicular to a chord is going to bisect the chord. So it bisects the chord and the arc. So what that means is it cuts the chord and the arc in half. Okay, So let's take a look at these problems. Now, these problems can get very confusing because there's not a whole lot that you know right now. All you know is that this little tiny segment piece is 6 and this is 4. However, together, LM is a radius. So the length of LM is going to be those two pieces together, 6 and 4, so that would be 10. That means that all radius lengths in the circle are 10. Because remember, all radius are congruent. All radius in the same circle are congruent. Okay, so that's an important rule that we need to remember here. So I don't have another radius right now, but what they're asking me to find is the length of this entire line NP. Well, now here's what you know. You have a radius crossing a chord at a 90-degree angle. Radius crosses chord at 90. When that happens, these two pieces are equal to each other. Again, that's still not going to give us a whole lot. There is something you have to do every time to these problems, and the trick is to add a radius to the picture. You have to add a radius to the diagram in order to be able to figure this out. And what I mean is I'm going to put a radius in right here from L to P. I could have put it in from L to N. It does not matter which side you put it in, but you need to add at least one radius. Now, remember, all radius in the same circle are congruent. So if that radius is 10, that is now also 10. So that means LP is 10 as well. All right, so what did that do for you? Well, you just created a little tiny right triangle in there. And you can find out this measurement right here. So you have this length is 10, you have this length here is 6, and we're going to try to find that length there. So we can use Pythagorean Theorem to be able to figure this out. So 6 squared plus x squared equals 10 squared. We get 36 plus x squared equals 100. Subtract the 36, we get 64. Take the square root, x is 8. So that little piece right there is 8, which means, remember, we had a radius crossing the chord at a 90-degree angle. So both pieces are equal. So that side is also 8. So now to find the length of NP, we have to add 8 plus 8, which is 16. So the length of NP there is equal to 16. And just remember, whenever you have length, you don't put a symbol on top. Okay? Let's do the same thing for the next one. We know we have at least one radius in this picture right here, and it is GH. But we also have a right angle there, so that's important to know. So we have HG as a radius, and that is 17. Okay, we also have it crossing this chord right here at a 90-degree angle, which means it's going to cut the chord in half. When the radius crosses the chord at 90, it cuts the chord in half there. But again, I can't solve this the way it is. I'm going to have to add a radius to the diagram. I'm going to add in one little radius right here. You could put it here or here. It does not matter, okay, because all 4 of these will be 90-degree angles in here. I have a length of 8. And I have another radius that is 17. So H to F there is also 17. So what you have in this is a little triangle where you have a side that's 8, a side that's 17, and you need to figure out this right here. Because if we figure out that, that's our X value. If we figure out that little piece, we'll know what this piece is over here because they will be equal to each other. They will be the same. So we have to do Pythagorean Theorem to figure this out. 8 squared plus x squared equals 17 squared. We get 64 plus x squared equals 289. You have to subtract the 64 from the 289, and you get 225. Take the square root, and x works out to be 15. So that little value there is 15, and this is also 15. You had to find the length of EF. EF is going to be the 15 plus the 15, which is equal to 30. So all of EF there is 30. Okay, those can be tricky questions. All right, I would suggest that you might want to go back and rewatch them, how I did those. Don't forget 2 things. Every radius is the same length, and you can add a radius to the diagram when you need to. Okay? All right, good luck.